What's up, recappers? Ellis here. And if you think it's distracting to watch a lean, try living in one. Good day, recappers. Ellis here. Brazil may be known for its soccer supremacy, but one coastal city may be an AEC red card waiting to happen. Santos, Brazil has three major claims to fame: South America's largest port, its Pele-famed soccer club for which the mesmerizing forward netted 643 goals, rest in peace, you foot magician, you, and buildings with such a lean that the skyline looks like it's had too many caipirinhas. We're talking a whopping 651 beachfront buildings imperfectly plumb, with around 100 leaning so hard you can spot them from the sand, some as much as 2 meters off-center. So, what caused these concrete contortionists? Huge earthquake? Subterranean aliens trolling? A Fast and Furious set piece gone awry? Nope. Just good old-fashioned human greed. Back in the 1950s and 60s, Santos was a boomtown. The huge port plus dope coffee and post-World War II prosperity met a breakneck construction rush, and weak city oversight made cheap and fast the motto of the day. Developers decided to cut corners faster than an F1 driver who had to number 2 at the Sao Paulo Grand Prix, and lax building codes only exacerbated it. Instead of splurging on deep foundations that would reach bedrock, the devs opted for shallow foundations that barely scratched the surface. These cost-cutting connoisseurs built on a 7-meter layer of sand, sitting atop a bed of clay and groundwater. Over time, the weight of these high-rises squeezed water out of the clay, causing differential settlement, with some tower corners sinking several centimeters per year in the early decades. And MEP? More like WTF. Electrical problems defined some buildings decades, and there have been more plumbing issues than recent Googles of Maduro Nike tracksuit. Living in these leaning towers is an adventure in itself, what with tilted facades and skewed floors. I mean, imagine trying to hang a picture frame only to have it look like a Picasso on a heroic dose of psilocybin, or rolling out of bed. Literally. Residents report furniture that won't stay put, windows that won't close, and a perpetual feeling of seasickness. But hey, at least rooftop putt-putt courses would be mad fun. City officials insist these lean kings are structurally stable, but tell that to owners watching their property values dip. Most of these still-standing towers are serving as homes for people who have made peace with living inside a funhouse. Regular inspections and patch-up maintenance keep everything technically safe enough, which is probably the only sane response. Some owners try to fight back by leveling the floors, and there's been plenty of talk about straightening, with engineers having floated a variety of ways to jack them back into something resembling upright. The catch? The price tag is so massive that only 2 towers have actually had the full architectural chiropractic treatment so far. Straightening them meant deploying giant hydraulic jacks and building new subfoundations beefy enough to hold the line against future subsidence. We'll see if that exorbitant venture becomes a blueprint. But boy, do we know what could have mitigated the great mid-century Santos slant or even prevented it outright. Reality capture and adjacent innovation. Yes, we know the tech was not around in the 50s. That's not the point. Dissecting the how and why of innovation is. Because cost-cutting, settlement turmoil, and lean far beyond PISA are still around. See, here's the kicker about reality capture and construction tech. They don't magically cure human greed, but they do make it a lot harder to hide, like your gut after leaving a churrascaria. The shortcuts and mishaps that set Santos up to slouch are still happening today, round the globe. So, about that tech. Before construction, one could have seen the ground's deception. High-res surveys uniting laser scanning, advanced imaging, and modern geophysics a la seismic refraction or ground-penetrating radar could have revealed that those cheap, shallow foundations were sitting on a 7-meter sand trampoline over squishy clay. Integrated with geotechnical borings, a digital terrain and subsurface model would have turned that bargain into a blazing red flag during design, instead of a lifelong regret after occupancy. During construction, one could have verified instead of just trusting. Routine drone flights combined with 3D capture and advanced metrology could have repeatedly compared the as-built structure against the design model. AI-driven change detection could have flagged early differential settlement, vertical drift, and alignment issues automatically. And how about some simulation of devastation? A BIM-integrated geotechnical model could have played out long-term consolidation of the clay under load, showing how those value-engineered footings would translate into decades of drift, cracked finishes, and sloped floors. Because nothing kills a bad idea faster than watching its 30-year animation sag across your screen like Blockbuster store counts. In operation, one could listen to the building. Today's structural health monitoring systems, think here tilt meters and IoT sensors, some deployed or inspected using robotic or semi-autonomous systems, could feed a digital twin tracking millimeter-level movement in near real time. Machine learning models trained on that data could reveal slow, creeping trends humans tend to normalize, turning progressive lean into an early warning system instead of a decades-later surprise. So next time you're in Santos, bring a level, a good sense of humor, and maybe one of those airplane yak bags. In a world where buildings can still end up doing the samba when they were designed to stand at attention, reality capture and allied innovation are how the AEC world stops pretending it didn't see the first step of the dance.